Hi, my name is Julia Silge, and I'm a data scientist and software engineer at our studio. And today, in this screencast, we're going to use some recent Tidy Tuesday data on collegiate sports in the U.S. and understand what affects expenditures, like how much a college spends on a certain kind of sports teams. We're going to look at things like gender, like are there differences between men's and women's sports, like what sports have the most money spent on them. And so it's, instead of being more of like a predictive modeling kind of screencast, this is more about how do you build models, and then how do you handle the model coefficients and understand, how the uncertainty with them and how to handle them. Let's get started.
All right, let's learn about college sports. So like I said in the intro, we're not so much going to take a predictive approach here where we try to predict something, but instead we're going to focus on understanding, like what can we learn to understand about these relationships in this Tidy Tuesday data on collegiate sports. So there is a lot of stuff in here. So we have for different years, like if we scroll down, we get to a different year. We get for different colleges, like and information about the college, including what division it's in. And then we understand like how many uh how many women and men participate in various sports, the revenue that is generated, and the expenditures as well. As you can see here, we've got skiing and rodeo and all kinds of track and field and lots of different kinds of sports here. So that's kind of the way this is going. Let's look at how many sports are there, and let's see what the sports raw sports. Let's see what's in here. All right, that's a lot. I notice there's some overlap here probably. So I think I'm going to do just a little bit of cleaning up here. Like notice we've got all track here and then divided out track. Probably, for like different kinds of schools and whatnot. We've got swimming and diving, and we've got diving, we've got swimming. So let's do just a little bit of manipulation of those categories before we keep going on. So let's take sports raw. I'm going to change the sports column, and I'm going to use case when, which I love. And so I put a series of conditions here, and then when this condition is true, have sports be this. When this condition is true, have sports be this. So I'm going to say if I detect swimming, let's call it swimming and diving. And let's do the same thing for diving. And then let's do the same thing for track. Except we're just going to say if we detect track, we're going to call it track, like that. And then I need one more for everything else. So it does these in order. So let's call this means all the rest of the time. It's a condition that's always true, and we just put sports in there. So let's call this sports parsed, like that. And we can do the same thing we did here to see what ends up after we do this. Like that. All right, so we shortened our list. Now instead of all different kinds of track, we just have track. We only have swimming and diving. I think I'm going to leave the rest of this as is, I think. But the next thing I'm interested in is what is that classification? Because okay, so there are all kinds of schools in here. I went to like a big NCAA Division I school for undergrad that had like an enormous football program, but there are so many other different kinds of collegiate sports out here, and this really just emphasizes how what these different divisions are like and how they're categorized. So this is important to know. This is so the observational unit here in this data set is a team. And so that is going to be important to think about as we move forward. So if you notice here, we have, it's actually maybe like sport. It's one observation per sport and school. And this particular data is often used to kind of look at like what is the status of women's sports in colleges. So I think what I'm going to do is I'm going to change the structure of this data a little bit before I make my model. So I'm going to do something like this. I'm going to say if I take sports parsed, and I'm going to select year, I need that. So it's one row per year, per college, per sport, per year and college and sport, but men and women are both in each row. So I'm going to change that a little bit. Let's take institution name, the sport that it is, and then I can't remember what they're called. Like this. Okay, so then let's call participants. So let's do men first. So participant men. Let's call revenue rev men, and let's call expenditures. That's getting a little long. Well, it's not any longer than participants. Expenditure. Let's call exp men, like that. All right. So, and then let's add a column that says, okay, this one, the gender of this sports is men, like this. Okay, so notice, men don't play soccer at this school. Men don't play softball anywhere, So we've got a lot of NAs in here, so we're gonna filter those out. So let's take this. Let's make another one that's for women, like that. Women, like this. And then let's bind these together. So bind rows like this. So we'll put this one in here. We'll put a comma, and then we'll put this one in here. So we're kind of reshaping the data a little bit, or reorganizing the data. So now, and let's get rid of all the, like that. So now this can be a data set that we can use for, other kinds of exploration or modeling or anything. So we have one row per year, university, sport, and gender. And it tells us how many participants there are, the revenue, and the expenditure, like that. So let's call this sports. All right, and this is a pretty big data set. Which lots of schools, I guess. So, we can do all kinds of EDA here. I think I'm just going to make like one plot that shows these teams and kind of the distribution of how much is spent on these teams. So I am going to, I'm going to put expenditure on the x-axis, sport on the y-axis, and then I'm going to fill by gender, like that. And then what I want to do is a box plot, like so. So let's make the fill less, like that. Okay, so let's start with this and then iterate on this. Okay, so first thing I want to do is I'm going to put that, look at football. That just really tells you right there, right? Like what's going to be a huge impact in this. So let's put that on the scale. We don't need that y-axis label. I think it's pretty clear that it is a sport. And so just to be clear here what it is here, this is expenditures per team. Like that. Okay, that looks pretty good. Let's reorder this. So mutate, sports, fact, reorder, not recode, reorder. And so we put in what we want, what we're starting with here, and then what we want to reorder it by. So let's reorder it by expenditure per team. Nice. Okay, this is looking good. Color fill. These are dollars, so let's put it on there. Labels equals scales dollar, like that. Oh man, I mean that's just intense, right? Like 10 million. Like this spans from 1,000 to 10 million. So one thing we can say right off the bat is there is a huge heterogeneity in how much is spent on different sports. So notice that these single gender sports like football and field hockey, their bins are twice as big. So and that that it doesn't really make sense in this context. So the way that you do this is by changing the position, and you put in this dodge, and see that default there, preserve equals total. If we say preserve equals single, that makes it so that they're all the same width. So now, like, you see football is the same width as this one, even though there's no women who play football, no women's teams that play football in this category. Let's I'm just gonna say no pink and blue for this gender category. I like the Brewer palettes. And let's call this one. Which one do we want? There's one that's nice. It's called Dark 2. I like that. Oh, and I don't know. I usually put labs last. It doesn't matter, but like that. All right, that's pretty good. It might, I'm just gonna do one more thing because I think it will help. So you can change elements of the theme by calling theme. And I'm going to say legend position. I think that's the simple one. And let's just put that at the top. The bottom might be good too, but yeah, I like this. Okay. Can I zoom in and look at this any better? There we go. Okay, so this looks pretty good. So let's notice some things. If you look at any individual sport, like even basketball here, it looks like there's not a huge evidence of differences overall in how much is spent per team in basketball. We do have, there's more outliers here. And let's look at another one, like swimming and diving. We don't see a huge evidence for in this plot for difference in how much men's and women's swimming and diving teams, how much is spent on them. There is a big difference in beach volleyball, but less is spent on the men's teams, so that's kind of interesting. But what we should notice here is that football, which is a team that only men play, and baseball, which is a sport that only men play, these are up high, really high. A ton of money is spent on them. And you don't get to a sport that only women play till softball, and it is below both of those by a fair amount. I guess we could combine softball and baseball if we wanted, if we treated those as the same. So there are single gender sports that there are big differences in the single gender sports, especially at the top end here, which, as we say, remember, this is on a log scale. So this is like bananas amount of money, just super intense. Okay, so now let's go into some modeling. So instead of trying to accurately predict something, like taking like a predictive approach to this, instead what we're going to do is we're going to talk about how can you use tidy tools, how can you use tidy models to understand model coefficients. So first, let's just build some just really straightforward models using LM. So this is like native R models. So let's make one model where we don't take into account differences in sport. So we're going to say expenditure is explained by gender plus participants. So what we're saying here is, you got to pass in the data. So what we're saying here is for how much does the expenditure per team change based on how many participants there are? Like, do you spend more money on bigger teams, which we would expect to be yes, I think. And then how much does expenditures change by gender? And now let's do the same thing, but I'm sure you're seeing where I'm going with this, and let's account for sport. So I'm just going to call it account for sport, like this. And here let's add in that sports variable that we have. Okay, so these are just two models, super fast. We're just training them one time. This is a pretty big data set here. So, but it's super fast. We all love LM, right? Like can't go wrong. And now let's look at these results. So you can, of course, do something like summary, let's see, ignore sport like this, and we get like a print method that shows us things. But if we actually want to make some kind of plot, or if we want to, manipulate this, what we want to do is we want to tidy it to get it into a form that's easier to deal with. So let's load the Broom library, which is, or the Broom package, which is part of the Tidy Models framework. And what we can do here, instead of summarizing it, we can do tidy ignore sport, and this gives us not print output. This gives us a tibble. This gives us a data frame that we can manipulate here. And you can see we've got our p-values, we've got the estimate, and all for these various things. So we can do kind of what we did up here with binding these rows together. That's one of the nice things about when you're dealing with models using a tidy tidy approach. We can just treat it like a data frame, which we're so used to using here. So let's say tidy account for sport. If we do that, I've got to add a column to tell what these are. So let's add a column here that says sport equal ignore. And let's add a column here that's sport equal account for sport, like that. So now I know which ones are which, like this. So let's make a plot. Let's make a plot of the terms that these two have in common. So let's, for example, get rid of, let's get rid of the terms that start with sports, like this. And let's not put the intercept on there. The intercept would be like the mean, spent on a team for men with 0 participants. That's what the mean is here. I might very briefly say, notice that when I made this plot, I had to put it on the log scale. One way to improve this model might be to model the log of the expenditure. But I think in the interest of having these mean dollars, like what I get out mean dollars, I'm going to keep it not on the log scale. That would be something to think about trying to make it better, though. I don't really care about the intercept. Term not equal to, it's got those darn parentheses. There we go. Okay, great. So I can look at this in a table. I could present this in a table, but let's make a plot with it. So let's put estimate on the x-axis, term on the y-axis, color equals sport. And so we can put the points on like that. But remember, we also have standard errors. So let's put those on too. Let's put them behind the points. I'm going to use error bars. And so I've got to add some AES here. So we'll say x min equals that estimate plus the standard error, x max estimate minus the standard error. And yeah, okay, let's make those, let's bump up their width a little bit, because otherwise they're so like thin and fine. Let's bump down the alpha. So okay, so let's do this and look at it. Okay, so this is a standard error. So you probably remember from your, if you've had like exposure to various statistical things, like how much we multiply the error by is like what our like which confidence interval we're trying to get here. So I think we'll do this because I think it'll be easier. I notice I'm going to do bootstrap later, and so if I just use the defaults for what comes out of the bat, we want to do it like this. Okay, let's do a few more things. On the x-axis, this is again dollars. Scales equal, no, what am I doing? Okay, labels equals scales dollar, like that. So what this is, let's add a 0 line. Vertical line. So the x-intercept is 0, like that. Okay, so that tells us where no effect is. So participants is on the y null color. Then we said, so we could do something like this, like include sport in model, like so. Okay, this is good. Okay, so notice here, so the participants is on the positive side, and so that means that that the more, this is the impact of one participant. How much does one participant cost, or how much do people spend in expenditures for every one participant? So that's what this is. Notice it's positive. Now let's look at this over here. When we look for a difference between women's sports and men's sports. So if we ignore what sport they're playing, then look at this, like this huge difference in for women's sports. Like it is, I mean, like $100,000 less, right? Per team. But if we account for sport, like, so what this question is asking, then what's here in the blue, this is saying, for every, like, do colleges, you have the same expenditures for women's and men's sports per team, overall. And then what the pinkish color is saying is, like, in any individual sport, like swimming or basketball or rodeo, do colleges expend different amounts per team? And so see how different the answer is here. There isn't a difference when we account for sport, and there is when you look at the sports overall. So what this is highlighting is that it is, it's probably just all football, right? Like the effect of football is so huge that and so much money goes into football teams that we see this kind of difference. Okay, so what I used here was the standard intervals that we get out from LM, but sometimes you don't want to do that. Sometimes, so when you do that, you're using the assumptions of OLS very heavily, and maybe like you want to create more robust intervals, and to do that, you can create bootstrap intervals. So instead of so if I were to look at this again. So when we do bootstrap intervals, we basically we ignore this altogether, and we just fit the model a whole bunch of times with resamples of the data and say, hey, how much does this change? Like, what do I get every time? Like, what is the distribution of answers that I get for the impact of, say, women's sports compared to men when I fit it a whole bunch of times? So I think the Tidy Models provides a really fluent way to do this in the R sample package that is called reg intervals. There's a lot of different ways to do this. This is like the dead simplest. You basically put in the exact same input as you had here, and then you wait because you're going to do it a whole bunch of times. So let me just copy this. I'm gonna adjust their names. I'm gonna say, let's call this ignore sport intervals. Ignore sport. This is better. Intervals account for sport intervals. And what I do is I change LM to reg intervals like this. It is like the same kind of input. I am, the times, we're going to do just the default, which is these T intervals. And this is a pretty big data set. I don't think I need to do it that many times. If you have a smaller data set, which is also a reason why you might want to make these kinds of intervals versus using the standard ones, we might want to keep that at the default, but 500 is pretty good still. Oh, also these use resampling. So I am going to set a seed, I'm going to set it twice just in case I come back here and run one of these versus another. And then let's start it. Okay, so but remember when I fit 2 of these models, it basically finished before I stopped talking. Let's start this, and I may need to just pause the video because now we're doing it 500 times. Actually 1,000 times because we're doing it 500 for each ones. So instead, and this is a pretty decent sized data set, right? Like remember it had 100,000? Yeah, no. I'm gonna have to scroll. Yeah, like 130,000 rows in it. So this is gonna take a little bit for this to finish. So just to remind us what's happening, um, uh, in each of these 500 iterations, we're taking a new bootstrap resample of the data and we're fitting a model to it and recording what was the effect on gender, what was the effect of participants. Okay, the first one finished. So if I keep talking, maybe the second one will finish too. So we did that 500 times now, just looking at the impact of gender and number of participants on expenditures. And now we're doing it with taking it into account sports. Yeah, I'm going to pause the video here and then come back when this one finishes. All right, we're back. It's done. And now we have these intervals. So let's look at them. So now instead of an estimate and a standard error, we have a estimate and lower and upper bounds given this was the default. I didn't change it given the significance level that we're thinking about. So great. So let's look at the other one. Nice. And let's do something we didn't do for the last. We could have, but let's look at this in a little more detail. So let's just take out the terms that are about sports, and we can explore this in quite any way that we want. Like for example, let's look here in descending order. What models? What sports have the biggest offset? Like if you have so the way the linear model like this works is it's saying, okay, for if you have a team, how much more expenditures are there on this team, this kind of sport team versus another? So notice that, look at this difference. Like football is like 3 times as much as the next one in the way that we have built this model. Gymnastics, expensive. Who knew? I didn't know. And then we've got like ice hockey. I guess you have to have a whole ice rink. Maybe that's why this is all expensive. Basketball, horses. Horses are expensive. But notice we're here now in the $100,000 range, not the million range. So we see this. The way this model works, we assumed that any given individual, like participant, moves the expenditures up the same amount. But if we wanted to do something like, hey, how much more does a football player cost than a field hockey player, then we would have used an interaction term. I'm not going to go back and do that though. So we'll just stay with this like simpler model. Okay, so let's see if we can like see differences here. Let's take this and paste it down here, and now we have the ignore sport intervals, the account for sport intervals, and we want to do that same thing. I don't think there's any intercepts anymore. That was a if you want the intercept, yeah, here's like the filter here where we didn't keep the intercepts. You can turn that off if you don't want anything there. So we can take that out because it's not there. And then it's dot estimate. And what else do I need to change? So now instead of this, like deciding ourselves, we are going to do lower and upper because we decided on the confidence or the significance level when we did the intervals. Anything else? I think that's the same. I think this is all right. Let's look at this. Okay. So let me just make this a little easier to see. Okay, so can we go back and forth? This is so nice. Okay. So notice a couple things. Overall, it's like the same story, right? Like, participants cost, about that much money. The When we don't account for sport, we see this huge difference between men and women's teams. When we do account for sport, we say, oh, the problem is not that in any given sport, or the difference is not because of any different sport they spend less or more. The difference comes because there are some men-only sports that there's an enormous amount of money spent on. So same general story. However, look, the intervals changed. Like, for example, so this right now here, we're looking at the bootstrap intervals. So the intervals for participant are bigger and the intervals for gender are smaller. So this kind of highlights how when you think of that different types of intervals get you different answers.
All right, so the eagle-eyed among you may have noticed that I was not working in an R Markdown document. I was working in rather than an RMD, a QMD, which is a Quarto document. I've started using them more and more, and I really like Quarto, so check it out if you're interested in that and learning a little bit more. In terms of the modeling and the data, what we learned today was that we see this, we see big differences in how much money is spent by colleges on women's sports compared to men's sports when you look at them overall, but that this is almost all due to the impact of single gender men's sports that get a ton of money spent on them, such as football. It's dominated, like that is just dominated by football. And when we look at individual sports, we don't see that really a significant difference in how much is spent on men compared to women's sports. So I hope this was helpful, and I'll see you next time.